In this part of 7.5, we'll be using the rational root theorem to find possible zeros of polynomial functions. So in this example, we want to use the rational root theorem to find our possible zeros of a polynomial function. So possible ones. They could be the zeros, they might not be. We're going to test them later. But the first thing it tells us to do is find p divided by q. Now, what is p and what's q? Well, we got to go over that. Well, p refers to our constant back here. Okay, so p here is 1, where q is our leading coefficient, 2. So q equals 2. What we want to do is we want to list all the factors of p and q. Well, the factors of p, which is 1, are basically just 1 and negative 1. So plus or minus 1. 1 or negative 1. For q, we have the factors of 2. So that'd be 1 and 2, and negative 1 and negative 2. So we're going to have plus or minus 1, plus or minus 2. So for all of our possible combinations of p over q, we have 1 over 1, negative 1 over 1, 1 over 2, and negative 1 over 2. Those would be our 4 combinations. Now, in order to decide which of these actually works, we're going to check the roots by graphing or synthetic division. We've got our graphing calculators handy. Let's use those. So I'd like you guys to plug this one here, 2x squared plus 3x plus 1, into your graphing calculator, and we'll see what we get. This next screen will show us some screenshots from the calculators. So we have our possible roots written down here to remind us. Now this is what you get when you first plug it in. You hit zoom standard and you get the regular window, and it's a little hard to tell where it crosses with just looking at this one. So what I like to do is hit zoom and then zoom in. So option number 2, so we hit enter, and then I hit enter again, and it will zoom in on the origin, which will show us our nice parabola that we have here. Well, I can clearly tell that it's crossing here at negative 1, and then for our other possible roots, it's 1/2 or negative 1/2. So I've got the negative 1, and right here, well, it's in the negative, so it's clearly going to be negative 1/2. So my roots here would be negative 1 and negative 1/2. Those would be my 2 roots.